Hello students, today we're going to learn P4, lines in the plane. So just to recall what you learned back in Algebra 1, slope is what we call a rate of change, and it's represented by m. It's also a rise or a run. We can also say it's a change of y over the change of x. So when you take calculus next year, you're going to use slope, but they call it a derivative. Okay? So in example 1, it says find the slope between 2 points. So the formula for that is y2 minus y1 over x2 minus x1. Here are the 2 points. Label x1, y1, x2, y2, just like the previous lesson, and all we do is substitute. So the slope between these 2 points is negative 5/3. And just to recall, whenever you have a negative slope, that means the line is decreasing. So I'll just draw a line here. That means the line is decreasing. So whenever the slope is negative, the line is decreasing. Example 2, find an equation of a line in point-slope form. So here's a point, here's a slope. Here's your slope, your point-slope form equation. So all we do is substitute these values in the formula. So there is y, x, and the slope. We simplify, and that is your equation in point-slope form. Please remember that this is the point, and m represents the slope. Example 3, find an equation of a line in slope-intercept form. So slope-intercept, slope is m, intercept is what the y-intercept is. So b is represented by the y-intercept. So here's your slope, here's your y-intercept. So this is what we call slope-intercept form. The point is 1, 2, slope is 1/2. So again, we start out by using point-slope form first. Substitute all the values in, simplify everything, distribute 1/2, add 2 to both sides. So when y is isolated, this is now called slope-intercept form. This is called slope-intercept form because the slope and the y-intercept are on the same side of the equal sign. Example 4, find the linear equation containing 0.61 and parallel to 3x minus 5y equals 15. In order to write a linear equation, we always need a point and a slope. Point, slope, point, slope. Here we have a point. We don't have a slope yet. But they say the line that contains this point is parallel to this line. Therefore, put this in slope-intercept form. Here is our slope. This is slope-intercept form. This is our m. So m is equal to 3/5. Now, back in Algebra 1, if line 1 is parallel to line 2, then m1 is equal to m2. So if the lines are parallel, the slopes are the same. So we're just recalling what we learned back in Algebra 1 or IM1. So we have a point, now we have a slope from here. So we use the same procedure, substitute all the values into our equation. So y equals 3/5 x minus 13/5. So here's our answer. If you notice, the two lines have the same slope, therefore the lines are parallel. Alright, example 5. Example 5 says find the linear equation containing 0.61 and perpendicular to this line. So we did all the work already from the last problem. So here is our slope-intercept form. The slope is 3/5. So what you have to recall is if line 1 is perpendicular to line 2, this is the perpendicular symbol, then m1, the slope of line 1, is the opposite reciprocal. So if the slope of this line is 3/5, the slope for this line would be the opposite. So opposite of a positive is negative, and the reciprocal of 3/5 is 5/3. So now we have a point and a slope. Since we have a point and a slope, we just substitute all the information back in again. So y is equal to negative 5/3 x plus 11. Notice the slope negative 5/3, the slope 3/5. These are opposite reciprocals. If they're opposite reciprocals, we know the lines are perpendicular. All right, example 6. Example 6 is we're going to use a graphing calculator. Now, to use a graphing calculator, what we have to do is first, let's make sure that y is isolated. Once y is isolated, we just substitute y equals, use this key here, negative 2x plus 35. Hit graph. And let's see, let's look at the window. Yeah, that's right. Alright, so when we hit graph, I think the battery's low. Just give me a second. Yeah, the battery is low. Okay, so it's y equals negative 2x plus 35. Let me adjust the window. So the window, since the y-intercept is 35, make this window the y maximum value that you could see, make it 40. And we can, let's graph now. Let's see what will happen. There it is. So what we did was, it didn't allow us to see it at the beginning because the window, the y value maximum was 10. So I adjusted it by putting it at 40 because I knew the y-intercept was 35. So the y-intercept is where the line crosses the y-axis. So when we graph, this line is decreasing. If this line is decreasing, that means that we have a negative slope. And again, the reason why I'm telling you this is when you take calculus, when the function is decreasing, the slope is, the derivative, the slope is negative. All right, so just future calculus. All right, so here we have 2100x plus 12y equals 3540. Get y by itself, so here's y. So now these numbers are large, so let's change the window. So to change the window, let's make the x minimum, let's make it negative 300. Let's make the x maximum positive 300. Let's make the scale, like how far apart are the tick marks. Let's make it 50. The y minimum, let's make it negative 3. Oop, that's wrong. Do not hit this symbol. It's this one. Sorry. So negative 300. Make the y maximum positive 300 and make the scale 50. So now let's graph. So there it is. The line intercepts the x-axis at 295 because we said the scales are 50. So 50, 100, 150, 200, 250, 300. So again, we have a negative slope. If the slope is negative, the line is decreasing. Let's just do another one. Let's graph y equals minus 100. So now the slope is positive. When the slope is positive, the line should be increasing. So let's do that. We could just graph another one here. We'll put 200x minus 100. Let's graph. So it's going to be, I think, the red color. Okay. So the reason why this graph is like this is because of our numbers here. Let's make this let's change this to 400. Let's change that to 300, just so we could see the graph. So we can go here, we can make that 400x minus 300. Let's see if we can get that in our window. So that's the first, that was this line. Okay, so again, I have to adjust the window to see that. What you could also do is you could zoom in, and you're going to zoom in right there. It's blinking. Okay, so it's probably out of range. Alright, so let's zoom back out. Zoom back out. Okay. Alright, that's it for today. Thank you.